All right, so here we're going to work with some trigonometric substitutions. Some things you need to remember. Keep in mind, sine of theta is equal to opposite over hypotenuse. Cosine of theta is equal to adjacent over hypotenuse. And tangent of theta is opposite over adjacent. Okay? And so if you look right below that, we have three different situations there where essentially we know 2 out of the 3 sides, and then we are labeling what the third blue side would be according to what we already had there of 3 right triangles. So these are all right triangles. Okay? And then what we're going to do is we're actually going to take advantage of this because we can use this as our substitution. All right, that right up there, what x is going to be. So if we look at that, we can go through and start doing some stuff here. So we have tan theta is opposite over adjacent, which is x over a. Okay. Then, oops. What's that? Nobody? Oh, I thought somebody said something. All right. So then we multiply both sides by a, and we get a tan theta equals x. Doing this from our first little picture there on the left. So a tan theta. So we want to use this for substitution with square root of a squared plus x squared. And so what we'll get is a squared plus x squared equals a squared plus well, let me do it this way. Let me write a tan theta squared, which will then equal a squared plus a squared tan squared theta, at which point I can factor out an a, and I'll get a squared times 1 plus tangent squared theta. What is 1 plus tangent squared? Secant squared. So this is a squared times secant squared theta. And now if we take the square root of both sides, we end up with a squared plus x squared equals a squared secant squared theta, right? And so we can take the square root of both sides. That gives us our a squared plus x squared square rooted, right? And then we just get a secant theta. Okay, and that's what we had up here. The absolute value of what? It's squared, so it would become positive no matter what. So yeah, you could write that on there. Yeah, here, there you go. Squared, square rooted, so it's going to be absolute value. Okay, so how do we use this? What do we do with this? First, you're going to write down the substitution for x, calculate the differential dx, and specify the selected values of theta for the substitution. So we might have to limit this to a certain range of thetas. Substitute the trigonometric expression and the calculated differential into the integrand, and then simplify the results algebraically. Integrate the trigonometric integral, keeping in mind the restrictions on theta for reversibility, and draw an appropriate reference triangle to reverse the substitution in the integration result and convert it back to the original variable x. Sounds super easy, doesn't it? It's really not that bad. Okay, let's try one. So here we've got integral of dx over 4 plus x squared. So which situation from before is that? That's, which one of these three ones is it? The leftmost one. That's an a squared plus x squared, all square rooted, right? So we're looking over here at this guy. All right, so let's come back over here. And this is essentially this is our square root of a squared plus x squared, which in this case, what is a? No, 2, right? A squared, so it's the square root of 4, 2. So a is 2 there in that case. So that's what our a is. That means we're interested in x equals 2 tan theta, right? That's our substitution. A tan theta, so 2 tan theta. Okay, and now we need a restriction on theta. Okay, and that is when we look at secant, we're up on that positive side from negative pi over 2 to pi over 2, right? If you think about the secant graph at negative pi over 2 and pi over 2. We have this thing, right? Outside of those, it repeats, and then we go negative and stuff. So we're going to restrict ourselves inside of there. So we'll say theta from negative pi over 2 to pi over 2. Okay? So if that's what x is, what is dx? What's the derivative of tangent? Nope. Oh, yes, I'm sorry. What am I thinking? I had secant tangent still in my head. Secant squared theta and then d theta. All right. So our 4 plus x squared equals 4 plus 4 tan squared theta, because that's what our x is, right? Which will equal 4 times 1 plus tan squared theta, right? This is just what we were doing before, which is 4 secant squared theta. Okay? So our integral of dx over square root of 4 plus x squared is going to equal the integral, and we're going to make our substitution here where we have 2 secant squared theta d theta. That's from this. 2 secant squared theta d theta. And then we have 4 plus x squared, which we just said was equal to 4 times secant squared. So this is square root of 4 secant squared theta. Okay? And then this will just equal, we have the square root of 4 in the bottom, so that's a integral 2 secant squared d theta, or secant squared theta d theta, over 2 times secant theta. I even put the absolute values there this time. The 2's will cancel. And now we remember we restricted our theta to just positive ones. So does the absolute value matter anymore? Because no matter what secant we take, we are staying between negative pi over 2 and pi over 2 on theta. So this integral becomes secant squared theta d theta over secant theta, because we said theta was negative pi over 2 to pi over 2. So we're only getting positive secants. Then this becomes the integral of secant theta d theta. And what is the integral of secant? Okay, but now we have theta in there. We need to get back to our original x, correct? Now, we can come down here. Let me change color. We can say tan of theta is x over 2, right? That's our triangle we were using. Right, this right triangle we were using, where this was 2, this was x, and this was square root of 4 plus x squared. Okay, that's just this triangle right there. Okay, so that's our situation. Remember, we're working entirely in that one right there. So we come back over here. Tangent is going to be x over 2, right? Because this is theta. Then we can look at secant theta, which is 1 over cosine of theta. Cosine is what? Is 1 over the adjacent over hypotenuse, right? So it becomes hypotenuse over adjacent, which is square root of 4 plus x squared over 2. Okay? So we already have that tangent. We're looking at this now. I won't this move anymore. Move down. There we go. So this will become natural log. Our secant is square root of 4 plus x squared over 2. And tangent is x over 2. So we just use that triangle to figure out whatever trig values we had left, right? In terms of x, plus x over 2 plus c. What do we think? Pause it here. All right, so back to looking at this one. So for this one, we're looking at which of our situations there. If we go back to the beginning, we have an a squared minus x squared, right? Is that what we're looking at there? So if we go back, where was the first page here? A squared minus x squared, which situation is that? It's this middle one, right? We're looking at that one. That's our situation number 2. So we'll keep referring back to that picture. So you need to be able to basically just draw out all 3 of these and go for it. Okay, so now we come back over here, and we're using a equals what? 3, good. And so x is going to be 3 sine theta. That was our substitution, right? 3 sine theta, right? Or a sine theta. When you come back over here, a sine theta. Okay? Now, we'll come back and we'll do dx equals what? 3 cosine theta d theta. There we go. Now, we're looking at cosine. We need to know where cosine is greater than 0. So this is where we're going to restrict our theta, right? So where is cosine greater than 0? Where is it positive? There, right? On that little curvy part at the top, because it continues on like this and goes negative and stuff. So where are we going to restrict ourselves? Yeah. So negative pi over 2 and pi over 2. So we want our theta to be from negative pi over 2 to pi over 2. Keep ourselves positive there. Now I'm going to do the substitution here stuff in just a slightly different order for you, okay? So, well, maybe I won't. That'll be a lot more writing. So we need to figure out what this 9 minus x this is here, right? The square root of 9 minus x squared is square root of 9 minus 3 sine whole thing squared, right? So 9 sine squared theta. And then this equals square root of 9 times 1 minus sine squared theta, right? And then this is square root of 9 is just 3, and then we're times the square root of 1 minus sine squared is what? Cosine squared theta. So we got the square root of cosine squared, right? So this is just 3 cosine theta. And yes, I put the absolute value for you again. Okay, so now we come in here and do our substitutions. We have integral, what did we have? X squared dx over square root of 9 minus x squared. Okay, so x is 3 sine theta. So this is 9 sine squared theta. Dx is 3 cosine theta d theta. And then our square root of 9 minus x squared is 3 times the absolute value of cosine theta. But again, we've restricted ourselves to where cosine of theta is positive. So do those absolute values really matter? No. All right. So that means we can cancel this 3 cosine theta with that 3 cosine theta, correct? Which means we have the integral, or 9 times the integral, of sine squared theta d theta. And we can do our substitution here. 1 minus cosine 2 theta over 2 d theta, right? That's what sine squared was. Our power reduction, right? Power reduction one. I can't remember that. Is that the half angle one or the power reduction one or the, but it also reduces the power. So I think they're the same one, right? I don't know. Is there a power reduction one that's different than that? Reduces the power. Anyway. So then we've got this. We can bring that 2 out in front, or that 1/2, 1 over 2. And now we have 1 minus the cosine of 2 theta. And so the integral of 1 is just theta. What's the integral of cosine of 2 theta? Over 2. Keep that minus sign, right? And then that plus c. So we get 9 over 2. So we get we can 9 over 2. I was debating about whether or not I wanted to distribute that 1/2 yet. So 9 over 2. And then we have theta minus that sine 2 theta over 2. So theta, anybody know a substitution for sine of 2 theta over 2? No? This is one I would use e to the I theta for coming up with. I do e to the I 2 theta. I think I did it e to the I 2 theta equals e to the I theta squared. And I'd set those equal to each other, work out both sides, and it'll come out of that one. But anyway, if you want to try that, it's a good exercise for you. And what we end up with is sine of 2 theta over 2 is actually just sine theta cosine theta plus RC. Okay? And now we need to figure out what our stuff is. So we need our reference triangle. All right, our reference triangle, go to red. Look like this, right? Where we had A over here, which was 3. This was theta, this was x, and then this was square root of 9 minus x squared. Okay? We need theta, which if we do, we get theta, or we can say whatever it is, we can do really, I guess, any one we want, but let's do sine theta equals x over 3. That's a simple one, right? Opposite over hypotenuse, which means theta equals arc sine of x over 3. So we got what theta is. Now we need sine cosine. Well, we just said sine was x over 3, so we've got that. And then cosine is square root of 9 minus x squared over 3. So now we have all three of those things, and we can go in and do our final substitution back over here. 9 over 2 we got 9 over 2 times arc sine of x over 3. Then we have minus, and we need these two things multiplied together. We need x over 3 times that 9 minus square root thing. So we end up with x times square root of 9 minus x squared over 9 times, here, let me put it in parentheses. I was going to flip it in there, but listen. So this is 3 times 3, this is 9, just like that, right? And then plus c. We'll just do one more step. So now we'll distribute the 9 over 2. Okay? So you end up with 9 over 2 arc sine x over 3. The 9s will cancel here, and we end up with x square root of 9 minus x squared over 2 plus c. What do you think? Get you started on this one, where square root of 25x squared minus 4, that's none of our situations, because we need an x squared minus a squared, right? So we don't have that. So this can equal square root of 25 times x squared minus 4 over 25. And then we can bring that 25 out, take the square root of it, and get 5 times the square root of x squared minus 4 over 25, which is 5 times the square root of x squared minus 2 over 5 squared. Okay? So I'll leave you there with this one. You have that other triangle. You can probably guess. We had 3 triangles. We're doing our third example. You should be able to guess which one it should be, but there is only one that's x squared minus a squared. So, okay, I'll pause it there. Y'all have 4 more minutes left.